Assalamualaikum. Hi guys. In this video, I'm going to introduce about percentage yield. Percentage yield is the ratio for actual yield to the theoretical yield multiplied by 100%. So this is the formula that you have to memorize in order to calculate the percentage yield. Let's go to the introduction. How the actual yield can be obtained. So actual yield is coming from the question. Usually, we do it in experiment. However, for the theoretical yield, usually it will comes from our stoichiometry. So this is where you have to understand how to write the stoichiometry. Next one, yield is referring to the product. So product can be given in many forms, which the first one is mass, whether in gram or kilogram, and the second one in terms of volume, whether milliliter or liter. So let's try one example how to calculate the percentage yield based on this question. I have here is example 22. The combustion of KCl in excess oxygen gas gives potassium chlorate. You have the equation, and now I'm going to check whether my equation is balanced or not. So you have 2 potassium, and then you have Cl, 2 of them, and last but not least you have 6 oxygen. Let's continue with extraction of information. The question said that if 10 gram of KCl is used in the reaction, you have to calculate the mass of product, percentage of product, if the actual yield of KClO3 is 11.850 gram. So how you want to continue for this part? We are going to go one by one by taking out the information given. You have here is the mass for KCl, one of your reactants. I put below it, and then you have to determine based on question A, what is the mass for my product here. So the one that I need to find out. And the next part, you have to determine the percentage yield for my product. So let's go one by one. We have question A, which will be the mass of KClO3 produced. Based on information given, this mass, I can calculate the number of moles for KCl. I will have 0.1340. Next one, we are going to compare based on stoichiometry of KCl with KClO3. If you realize here, I said before, you have to compare the stoichiometry with the limiting reactant once you already confirm which reactant is. So in this case, I want to emphasize why KCl is limiting reactant, because you got words here, excess oxygen gas. So automatically, oxygen gas will be excess reactant. So let's get back to the question. You got number of mole for KCl. So I'm going to do my stoichiometry. I will have X mole for KClO3. I rearrange equation. I will have 0.1340 mole of KClO3. But right now, the question asks you about mass. So, mass of KClO3, the mole times with molar mass, you will have 16.4150 gram. So this is the theoretical yield. Why? Because this is the value which coming from the stoichiometry here. Now let's go to question B. I want you to calculate the percentage for my product if actual yield is 11.850. So as I mentioned before, actual yield usually is given in the question. So now I'm going to continue by taking out the information. I got mass here and I got percentage yield that I want to find out at the product side. So, actual yield for KClO3 is 11.850 gram. So this is the one that I have given from the question. Next, you also got the theoretical yield for KClO3. So this is what you have from question A, 16.4150. And this value I calculated from stoichiometry. Next, we want to determine the percentage yield. I take out the information. Do I have actual yield? Yes, I have it here. Do I have theoretical yield? Yes, I have it also here. And you times by 100 in unit percent. So I put the value. I will have my final percentage yield is 72.1901%. So I hope all of you can understand how to determine the percentage yield based on example 22. Try to do a lot of exercise so that you can realize how far your ability is. So that's it from me for this video. I'll see you in the next one. Bye!